Welcome to Lesson 1. My name is Gerald Balakaki. We'll cover ER notations and conceptual design examples. Why relational database design is important. Efficient storage, fast retrieval, easy management. Backbone of any application. Poor design leads to complications. ER model, functional dependency, data normalization. We want to start with the design process. This is an overview of the design process. It comes in 5 phases: requirement collection, conceptual design, logical design, physical design, and implementation. Finally, the implementation is our final phase. Entity relationship model, or call it the ER model, a conceptual framework for understanding data elements and their association. ER modeling is based on entities and their relationships. Entities are things or objects with independent existence. Relationships are associations between entities. For example, author and book. An author writes books. Each book is written by one author. Relationships are bidirectional. We have 3 popular ER notations: chains, UML, and crow's foot. Chains use rectangles, ovals, and diamonds. UML uses rectangles with names inside. Crow's foot uses rectangles and crow's foot symbols. Attributes are listed within rectangles. Cardinalities are represented by numbers or symbols. Let's look at the one-to-many example. One author can write multiple books, but each book is written by one author. This business rule is represented in different notations. Our author writes many books. One book can be written by exactly one author. In UML, one author writes many books, and one book is written by one author. This is how the notation looks. Let's look at the many-to-many scenario. An actor can star in multiple movies, and a movie can have multiple actors. This is represented as M and N. In a UML, one actor can star in many movies, and one movie can have many actors. Lastly, the one-to-one scenario. Each user has one profile, and the profile belongs to one user. In UML, one user has one profile, and one profile belongs to one user. We'll focus on UML for its detail and wide use in computing. It communicates business rules effectively. Attributes define our entities. Single-valued attributes like an author name. Composite attributes have a hierarchy. Multi-valued attributes like contact info. Derived attributes are computed like age from birth date. Multiplicity combines participation and cardinality. Participation is the minimum number of entities in a relationship, while cardinality is the maximum. For example, an author writes one or many books, and a book is written by one author. This is a one-to-many relationship. UML helps specify these relationships clearly. A primary key uniquely identifies a row in a table and can never be null. A composite key consists of 2 or more attributes. A surrogate key is a generated number for identification. A foreign key references the primary key in another table. It enforces referential integrity between parent and child entities. This is an example of a college database conceptual design in UML. We use an ERD, the entity relationship diagram, consisting of main entities and relationships. This has been generated from the business rules. A college stores information about students, professors, class sections, rooms, and courses. A student must enroll in one or more class sections. We have a student and a class section. Nouns form as entities. We're interested in entity and relationship. This is just a conceptual design. One student must enroll in one or many class sections. One class section is taken by many students. This business rule is accommodated in these entities. Each class section is assigned a specific room. One class section is assigned a specific room. Each room can be used by several class sections. Each professor may teach many class sections. A professor may teach 0 or many class sections. One class section must be taught by one professor. A course has several class sections. One class section belongs to a specific course. This is an example of a UML conceptual design. Summary: we looked at the design process. Next, we'll create detailed ERDs.